everyone, this is Kalpana here. In this video, we are going to prove a problem from mathematical induction. So let's get going. Problem: prove by mathematical induction that a power n minus b power n is divisible by a minus b for all n belongs to natural numbers. Okay, so here we are asked to prove the statement a power n minus b power n is divisible by a minus b for all n belongs to natural numbers using mathematical induction. So we know that solution: let P of n be the given statement, that is P of n a power n b power n minus b power n is divisible by a minus b for all n belongs to natural numbers. So here firstly we are going to prove that P of n is true for some natural numbers 1, 2, likewise so on. Okay, so we'll check whether P of n is true or not for n equals to 1, 2, 3 and so on. Okay, and in the second step we'll assume that P of n is true for some n equals to k, and then by using this assumption we'll prove that P of n is true for some n equals to k plus 1. Okay, fine. Now when n equals to 1, consider a power n minus b power n and put n equals to 1. Then you'll get a power 1 minus b power 1 equals to a minus b, right? We have to check whether a power 1 minus b power 1 is divisible by a minus b or not. Okay, fine. So here our dividend is a power 1 minus b power 1, which is a minus b, right? We'll check whether a minus b is divisible by a minus b or not. Obviously a minus b 1 times a minus b, right? Here 1 is a quotient, right? So here our dividend, we know that divisor into quotient plus remainder gives dividend, right? Divisor into quotient is a minus b into 1 plus remainder, that is 0, equals to, we have to get the dividend a minus b. See, a minus b into 1 is a minus b, right? So we'll write this a minus b, this one, as a minus b into 1. Okay, a minus b into 1. I'll write just dot 1. So here 1 is a quotient, right? And also here we are having multiple of a minus b. A minus b into 1 is a multiple of a minus b, right? And also it is divisible by a minus b, right? See, you are having a dash minus b dash equals to a minus b into 1. You can just write this as a dash minus b dash, sorry, a power 1 minus b power 1 by a minus b, which is equals to 1, right? You can also write this as a power 1 minus b power 1 by a minus b equals to 1. So from this we can say that a power 1 minus b power 1 is divisible by a minus b with quotient 1. Or we can say 1 is the quotient when a power 1 minus b power 1 is divided by a minus b, the divisor, right? So from this we can say that P of n is true for 1 belongs to natural numbers. That is, therefore P of 1 is true. So now we have showed for n equals to 1. Okay. So n equals to 1 satisfies the statement. Now we'll check whether P of n is true for n equals to 2 or not. Now when n equals to 2. Now our motto is to say that or to show that a power n minus b power n is divisible by a minus b for some n equals to 2 which belongs to natural numbers. Right? Let's see. Consider, just put n equals to 2 in a power n minus b power n. Then you'll get a square minus b square. We know that a square minus b square is a plus b into a minus b. Right? Again, it is a multiple of a minus b. So we can say that we can easily divide a square minus b square by a minus b. Right? Or we'll show you. We have to check whether a square minus b square is divisible by a minus b or not. Right? Since we know that a square minus b square is a plus b into a minus b. So, a minus b into a plus b gives a plus b into a minus b, right? So, here, this is our divisor. This is a plus b into a minus b is our dividend. And this is our quotient. And 0 is our remainder, right? So, just I'm showing you like this. A square minus b square is a plus b into a minus b by a minus b gives a plus b, which is a quotient. Okay. So from this we can say that a square minus b square is divisible by a minus b. Okay. We can write this as a minus b into a plus b. Multiple of a minus b. So here a plus b is a quotient. Right. Which is a multiple of a minus b. And also this is divisible by a minus b. Since you are having a minus b as your multiple here, so obviously we can divide this by a minus b. Okay. So from this we can say that P of n a power n minus b power n is divisible by a minus b for n equals to 2. Therefore, P of n is true for n equals to 2. From this we can say that P of 2 is true. Right. Likewise, we can show for n equals to 3. When n equals to 3. A cube minus b cube. We know that a minus b whole cube equals to a cube minus b cube minus 3ab times a minus b, right? Now, take minus 3ab times a minus b to LHS. Simply bring this term to LHS. We'll get a minus b whole cube plus 3ab into a minus b equals to a cube minus b cube, right? So now, we can replace a cube minus b cube by a minus b whole cube plus 3 times a minus, sorry, 3ab times a minus b. Again, we are having a minus b two terms in both the terms, right? So we can take a minus b common from these two terms and you'll get a minus b times a minus b whole square plus 3ab, right? So now a minus b, we'll check whether a cube minus b cube is divisible by a minus b or not, right? So this is a multiple. A minus b into a minus b whole square plus 3ab gives a cube minus b cube, right? Then just write a cube minus b cube as a minus b times a minus b whole square plus 3ab, right? Since a cube minus b cube is a minus b times a minus b whole square plus 3b, right? So we have replaced a cube minus b cube by this. So a minus b times a minus b whole square plus 3ab gives a minus b into a minus b whole square plus 3ab, right? The remainder will be 0. So here our quotient is a minus b whole square plus 3ab, right? This is our quotient. Terms under square brackets is our quotient. And also this term is a multiple of a minus b, right? A cube minus b cube is a multiple of a minus b, which is a multiple of a minus b. And also it is, this total expression is divisible by a minus b, right? We have checked now. And also is divisible by a minus b. Since if this term is divisible by a minus b, then a cube minus b cube is divisible by a minus b, right? Which is nothing but, since a cube minus b cube is nothing but a minus b times a minus b whole square plus 3ab. If this is divisible by a minus b, then obviously a cube minus b cube is divisible by a minus b, right? So from this we can say that therefore P of n is true for n equals to 3. Okay, from this we can say that P of 3 is true. So I have showed you the statement is true for n equals to 1, 2, 3. If you want, you can check for 4 and 5 and 6. Yeah? Savish. So we'll get a quotient, some quotient when dividend is divided by a divisor. right? Now, we'll make an assumption. Assume that P of n is true for some k which belongs to n, right? For n equals to k otherwise. Okay? For n equals to k, that is P of k is true for k belongs to some natural number. Okay, that is, we'll have P of k, a power k minus b power k is divisible by a minus b, right? For k belongs to n. Since we have, or we know that a power 1 minus b power n is multiple of a minus b, likewise a square minus b square is multiple of a minus b, likewise a cube minus b cube is multiple of a minus b, right? Here 1 is a quotient, a plus b is also a quotient, a minus b whole square plus 3ab is also a quotient. So all these expressions are quotients, right? Then for n equals to k also, we'll get into some quotient, right? So we don't know what exactly we'll get in the quotient, right? Let's name it as some q or some lambda or some m or some any symbol. Okay? Since we got for n equals to 1, multiple of a minus b with some quotient, and here also multiple of a minus b with some quotient, and for 3 a minus b into some quotient. Likewise for k also will get a minus b into some quotient. We can name this quotient with some q, say. Okay? Then a power k minus b power k will be multiple of a minus b with some quotient. Okay? So we can just represent it as dividend is divisible by divisor with quotient q with remainder 0, right? Which is nothing but divisor into quotient plus remainder gives dividend. We all know this formula, right? Divisor a minus b into quotient q plus remainder 0 must give a power k minus b power k, right? We have to assume this is true. We have already proved for n equals to 1, 2 and 3, right? For k, we'll assume, right? So now, from this you'll get a minus b into q equals to a power k minus b power k. Okay. So you can write this as a power k equals to, take minus b power k to RHS, you'll get b power k plus a minus b into q, right? Now, if you multiply, consider as equation 1. Okay. If you multiply both sides with a, then you'll get a power k into a equals to b power k plus a minus b into q times, okay, into a. From this you'll get, here you can add the powers, a power k plus 1 equals to a into b power k plus a, okay, or a minus b into a q, right? We'll just write this as plus a q into a minus b. Okay, consider it as equation 2. Since p of k is true, from this we have a power k minus b power k is divisible by a minus b for some k belongs to natural numbers. Again, from this condition we got two equations, right? A power k equals to b power k plus a minus b into q. We have considered as equation 1. And the second equation, a power k plus 1 equals to a into b power k plus a q into a minus b, which is our equation 2, right? Now, we have to prove that p of k plus 1 is true. We have to show that, or we have to prove p of n is true for n equals to k plus 1, right? So let's consider p of k plus 1, that is a power k plus 1 minus b power k plus 1, right? You can replace a power k plus 1 by this, or you can just split this as a power k into a minus b power k into b. Okay, let's see what happens if we split this. Then simply replace a power k by this one, that is by equation 1, since a power k equals to b power k plus a minus b into q, right? So now we'll replace a power k by b power k plus a minus b into q into a minus b power k into b is equals to a into b power k plus a minus b into q into a is a q into a minus b minus b power k into b, right? Now, let's write the terms involving b power k first. So here comes the first term and the third term, b power k into b, or b into b power k, okay, minus b into b power k plus a q into a minus b, right? So now we can take b power k common from these two terms and we'll get b power k times a minus b plus this term will be as it is. Now you're having a minus b in both the terms, so let's take a minus b common from these two terms. Then we'll get a minus b times b power k plus a q, right? Which is again a multiple of a minus b, right? A power k plus 1 minus b power k plus 1. So we'll see a power k plus 1 minus b power k plus 1 is divisible by a minus b or not, right? So you can replace a power k plus 1 minus b power k plus 1 by a minus b times b power k plus a cube, right? So a minus b into b power k plus a cube gives a minus b into b power k plus a cube, where we get the remainder 0, right? So here b power k plus a cube is our quotient, right? So this is our quotient here. Already in k we have quotient as q, so let's consider it as some q1 or lambda, anything. Okay, better let's take lambda, a minus b into lambda, right? So here a power k plus 1 minus b power k plus 1 is a multiple of a minus b, right? Which is multiple of a minus b, and also it is divisible by a minus b, right? See, this one is divisible by a minus b with quotient lambda, right? And also is divisible by a minus b. From this we can say that therefore p of n is true for n equals to k plus 1. Again, from this we can say that p of k plus 1 is true, right? Now we have used a power k and proved that p of k plus 1 is true. What happens if we replace a power k plus 1? Simply use equation 2. Replace a power k plus 1 by a into b power k plus a q into a minus b, and write this equation as it is, minus, or you can split b power k plus 1 as b power k into b, which is b into b power k, right? Now write the terms involving b power k first. You'll get a into b power k minus b into b power k plus a q into a minus b, right? If you notice, you're having b power k in first two terms, so let's take b power k from common from these two terms, and you'll get b power k times a minus b plus, write the second term as it is. Now we are having a minus b in both the terms, so let's take a minus b common from these two terms, and you'll get a minus b times b power k plus a q, which we have already represented this quotient. Here b power k plus a q is a quotient, right? We already represented it by lambda, then you get a minus b into lambda, right? So a power k plus 1 minus b power k plus 1 is a multiple of a minus b, right? A minus b into lambda is a multiple of a minus b, and also we can, it is divisible by a minus b, which we have already seen earlier, right? So from this we can say that p of n is true for n equals to k plus 1, right? P of n is true for n equals to k plus 1, that is a power k plus 1 minus b power k plus 1 is divisible by a minus b, right? We can include one more sentence here. A power k plus 1 minus b power k plus 1 is divisible by a minus b. So from this we can say that a p of n is true for n equals to k plus 1 and p of k plus 1 is true. Hence, by the mathematical induction or by the principle of mathematical induction, p of n is true for all n belongs to natural numbers. So here we have proved p of k plus 1 is true using our assumption that p of k is true, right? So, and also we'll get some question with some reminder 0 or with reminder 0. We can say whenever a power n minus b power n is divisible by a minus b for n belongs to natural numbers. Here a power n minus b power n will be our dividend for n belongs to natural number and a minus b will be our divisor. Okay. So we have seen a problem from mathematical induction in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.